Okay, I got a few questions emailed to me from presumably one of my subscribers. Let's have a look at these questions. They're all physics questions. So the first one here, a ball is thrown vertically upwards from the ground at a speed of 15. Approximately how long does it take to reach the ground again? So these problems here are called UVATS problems. UVATS problems. There's formulas to solve them. So we'll write down the information we know. A ball is thrown vertically upwards from the ground at a speed of 15. So U is 15 meters per second. The V we don't know. The A we do know. That's roughly minus 10. Because of the word approximately here, it makes me think that we can use the minus 10 rather than the more precise value of minus 9.81. Really depends on the course. The T we don't know, and the S we do know. The S is the displacement, meaning how far away the ball is from where it started. And if it's on the ground again, then it's displaced to 0. And the formula we could use is S equals UT plus a half AT squared. Would that do it? We have S, we have U, we have A, and we want T. So 0 equals UT plus a half A, so a half times minus 10 is minus 5, a half A T squared. If T is not allowed to be 0, then what we can do is divide this by 5T. So 15 divided by 5T is 3. And then 5T squared divided by 5T is T. So you end up with T is approximately 3 seconds. Okay. We can pause for a moment, clear it off, and have a look at the next question. Next question now. A ball is thrown vertically upwards from the ground. Okay, so another UVATS. This time the U is 15. Again, the A is minus 10. And at what height will the ball's velocity be 0? So it reaches a velocity of 0 in the end. And this time, the formula we'll need, we're looking for the S, I think. The height, the displacement, yeah. So V squared equals U squared plus 2AS is the formula we need here. So that means 0 equals 15 squared, which I think is 225. And then 2A, it's minus 20S. So solving this equation, you get S is 225 over 20. Oh, now there's a multiple choice answers which aren't on the screen. So that's going to be about 10, 11 seconds. I wonder now. Yeah, that's coming out at about 11 and a quarter seconds. So I'll pause for you, or you can pause as well to take note of that. Why did I write seconds? Sorry, I forgot what I'm looking for. Meters. 11.25 meters, not seconds, meters. Okay. Let's look at the next one now. A ball is thrown vertically upwards from the ground at speed 10. How long does it take to reach the ground again? Oh, that's the same as the first one. So, U is 10. V we don't know. A is minus 10. And S is 0. So, again, the same formula. S equals UT plus a half A T squared. And if T cannot be 0, then what we can do is divide by 5T again. So we get 0 equals 2 minus T. So this time, T is 2 seconds. Yeah. Okay. I'll pause again. Now, as I was saying, number 4 now is on to springs. So you have 2 springs connected in parallel. So there's 2 formulas here, series and parallel, for springs. If I remember correctly, the parallel formula for springs is that the constants add K1 plus K2. And then if they're in series, it's 1 over K equals 1 over K1 plus 1 over K2, I think. I could be easily confused on this because there's so many series and parallel formulas, resistors, capacitors, springs, that could be mixing it up. There's no harm for me pausing for a few seconds just to check Google. Yes, Mr. Wikipedia agrees with me. So if you add those two together, it's like having one spring of constant 24 newtons per meter. And then we want to know the extension when we have a weight of 12. So by using Hooke's law, F equals Kx. The extension x is F over K, which is 12 over 24, which is half a meter. Okay. And finally, a ball is thrown vertically upwards from the ground at a speed of 20. At what height will its velocity be 0? Same as earlier. U is 20, V is 0, A is minus 10. And we'll use the formula V squared equals U squared plus 2A S. So that's a 5. 2AS. So that means S will be 400 over 5. What's that? 80, isn't it? 80 meters? 80 meters. So the ball at a height of 80 meters is when its velocity will be 0. No, that seems wrong. That's way too big. What have I done wrong here? V squared equals U squared. Oh, oh man. V squared equals U squared plus 2A. I wrote down a half A. 2A would be 20S. I hope I didn't make that mistake earlier. So S is 400 over 20, which is 20 meters. I hope I didn't make that mistake earlier. That was in part 2. Let me double check that one. So again, V squared equals U squared plus 2AS. So 225 divided by 20. Yeah, 11.25. I remember saying that earlier. Yeah, so don't mix up your 2's and your halves, that's for sure. Okay, so the last one looks like it's 20 meters. Yeah, it's interesting how it worked out a nice round number like that. But I think that's because the speed was 20 and the deceleration is 10. So, yeah, okay. Okay, that's your questions. Basically, I can summarize them as questions 1, 2, 3, and 4. They're UVATS problems. You can find them in most physics and applied maths books. This one here, it's a little bit different. I don't usually see this in Leaving Cert physics. I usually see this in A-level physics and university physics. So, also, it's kind of interesting that the units here are in this slash form rather than the usual Newton meters. So, I know you said these questions came from a multiple choice quiz. I wonder if I can predict. So It's using 10 as G, but it has the spring question in it, and it has slashes too. Tell me if I'm right or not. I'm thinking that this is an aptitude quiz for graduates or mature students entering a program at university. That's what I'm thinking. Because it seems to be, I feel like it might have been written by a lecturer, and it has a little bit of stuff in it that is not quite on the Leaving Cert, so maybe they're expecting some prior physics knowledge. So, I wonder. Anyways, hopefully that is clear enough. They're short enough questions, and yeah, there you go. Let me know if you've spotted a mistake. I am quite tired, so if something doesn't seem right, just say so. All right.